In this tutorial, we will be demonstrating on how to use ThreeDidy XLSurfFit in Microsoft Excel. XLSurfFit is a 3D modeler add-in. Unlike other graphing programs, where integration with Excel is difficult, XLSurfFit works with your worksheet data directly within Excel. Also, unlike Excel Building Solver, that fits one equation at a time, XLSurfFit automatically fits hundreds or thousands of equations to your data and determines the best fit. Once installed, you can try XLSurfFit for free for 7 days, and afterward, you'll have to purchase a license to keep using it. Let's begin. Go to your Add-ins tab, click the Excel Grapher menu, and select New SurfFit Instance. From there you will need to select a range of cells dedicated for your graphic chart. By default, an empty 3D graph coordinates will appear. You can hold the left mouse button to rotate the view. You can press and hold the scroll wheel to pan around. Should you need to move, resize, copy, paste, and delete your graph, you will need to turn on the Design Mode button, as I will demonstrate to you now. When done, click the Design Mode button again to turn it off and to restore your graph. Now right-click on your graph and click the Add Update Cell Ranges item menu. Click on the Add X, Y, and Z button. Select a range of 3D data set. Close this dialog box to see the result. We can now modify our graph by right-clicking on the graph. Select Modify Graph Series. From here, select the name of your series, and let's make our graph look better. Let's change geometry type from points to surface and click Apply. We can also play around between options that are available for the surface. Next, click on the Color Intervals button. From here you can change the color intervals based on graph series, or by data intervals, which I am about to demonstrate. Close all the dialog windows. As you can see, we have just made a 3D graph series with the selected data set. This 3D graph series can be used as input to your SurfFit. To open SurfFit, right-click over your graph and select Equation Fitter. Note that, unlike XLSurfFit, which operates directly on cell ranges, XLSurfFit depends on the 3D grapher and operates on graph series within Excel Grapher instance. Click the drop-down menu Graph Series and select your graph series. Regarding the fitting target, this will specify fitting objective. There are 9 objectives to choose from, and the default is the lowest sum of squared absolute error. The smoothness field allows you to control on how smooth is your surface fit will be. Changing this value will change the resulting fitted equation formula. Under Equation Name, you find a list of all the equation families that are available for your surface fit. There are 17 equation families and 1,000 equations in total. You can select some of the equation families, or you can go in an equation family to select in detail an equation of that family. You can also scroll to the right to see the actual equation, or simply resize the window for a better view. For this demonstration, I will use the miscellaneous fit for my data set, as it's been tested to be the best fit. Click one of these 2 buttons. The difference between them is that Fit Equation Families to Data allows you to select multiple equation families, while the other button allows you to select single equations from different families. Since I only have one equation family, I will click on Fit Equation Families to Data. At this point, the process can take between few seconds to several minutes based on the number of equations that has been selected in total to be fitted in your graph. It also depends on how powerful your computer is. To finalize the process, click on Add Update Graph and close this dialog box to see the result. As you can see, the added surface is the fitted surface from the equation. You can see also the added curve is similar to the actual data set. Now let's go back to our equation fitting dialog box and see the details on the equations. Unlike curve fit, as you can see, some of the features are in read-only. These read-only fields are entirely reliant and based on the name and location on your graph. Under fitting output, there are several terms listed in here, such as the equation name, text and coefficients or values. There is also the x, y and z values. The z predicted value consists of the predicted value from the fitted equation at the specified x and y location. The absolute error is the prediction between the z predicted and z actual. As for the relative error, it consists of the absolute error divided by the z actual. Finally, the percent error is the relative error as a percent or multiplied by 100. All these details are given for all the x and y values in the data set. Next is the operators and functions field, which consist of a read-only list of all the operators and functions that are available. This list will help you on how to manually change your fitted equation. The variable and constants field displays the resulting variables constants. You can even modify the name and values if needed. You can also add or delete variables if you would like to try out some possible scenarios. Going next is the fitting equation field, which displays the equation used to fit your 3D graph. If needed, you can also modify this equation manually and click on Add Update button to see the result on your graph.